So the aerodynamic force is broken into components because aerodynamic force was a component of lift force and drag force, right? So we had F drag and F lift. And the aerodynamic force is the vector addition of those two. We can also define each of the lift and drag force by a coefficient. So a coefficient defines how big of a ratio you have of this overall aerodynamic force, this overall total. So lift gets the total aerodynamic force times a coefficient called C lift. And drag force gets the entire vector sum aerodynamic times a coefficient that is the amount of drag. So we can also rewrite explicitly coefficient of lift and the coefficient of drag. So coefficient of lift, therefore, is the force of lift. It's the lift force over the total force, which is called aerodynamic force. And coefficient of drag, then, is the drag force over the total force. So those are the coefficients of lift and drag. And again, what they do is they explicitly define how much of the aerodynamic force goes to lift or to drag. So it does not depend on how big a wing profile is, a blade profile is. It depends entirely on profile. So shape dependent. It is shape dependent, not size. So a profile that looks like a rectangular object is very different than what we have in a wind turbine, which is a airfoil type of profile. So how much lift force or how much drag force you can get into something depends on the shape of the object. So let's look at the particular shape that is used then in a wind turbine, in wind turbine technology. And a good airfoil wants, an airfoil is a shape that we use to make a lot of lift. Okay, so high lift force, high coefficient of lift is what a good airfoil has. So an airfoil is the shape that is on airplane wings as well. And of course, you want good lift in an airplane wing. So if you were to take an airplane wing, let's say this is your airplane, and this is a wing, and this is a wing. And if you were to cut a section of that wing, you were to cut a plane of that wing, then I'm using the word plane for a plane, but if you were to cut a section, then that wing actually looks like this. And it has that characteristic because that's a shape that'll make a lot of lift force, and you want lift to lift the aircraft up. So let's go ahead and try to make a nice airfoil shape. So an airfoil shape is about like this. The airfoil can have a center line. So this is a mean line where this distance is equal to this distance. So this is a mean line. So I'm going to call this mean line or center. So everywhere on this path, you have equal on either side. So that mean or that center line is going to be a little bit curved as well. And so let's define something here in an airfoil. If I go from this, the tip of this mean line, all the way down to the tail of this airfoil, then that is called a chord line. And if there is more material above the chord line compared to below the chord line, so if the shape is asymmetric, if it's an asymmetric shape, meaning there's more space above than below, then that is called a cambered airfoil. So what I've drawn here is definitely a cambered airfoil. We can label a few things on here. This is called the trailing edge. And this is called the leading edge of an airfoil. The center of gravity isn't really in the center of this shape. It's really sort of about here. I'm going to mark center of gravity there. The chord is the distance, just giving you some definitions here. The distance between the leading edge and the trailing edge is called the chord. So that's a distance called chord. And we can show on here, we can assume that the force, the lift force and the drag force are going to operate at the center of gravity. And a nice airfoil like this would do is it would have a higher lift force than drag force. So this would be force of drag, and relatively force of lift would be greater than it. And of course, the aerodynamic force is the vector sum of the two. So that's force of aerodynamics. And remember that either drag force and lift force exist, or force aerodynamic exists. All three of those would not exist together, because force of aerodynamics is equal to force of lift plus force of drag. So mathematically, you would be showing one or the other. So this is an airfoil shape. And the purpose of this airfoil, the reason why wind turbines are made out of an airfoil shape, is because it maximizes the coefficient of lift. That's useful for a lot of things, including a wind turbine.